We are getting ready for our last presentation before lunch. Jeremy Schulman's going to join us up here from Major League Baseball and talk about intent-driven automation. I think. No? Maybe he changed his mind. He's going to talk about something else now. But I just want to give a shout out to Jeremy is one of the driving forces behind this conference. We probably all wouldn't be here without his influence. So appreciate you coming up here for the talk as well as everything else you've done. I think Scott's getting you ready and we'll be good to go. Yep. Thanks, Jeremy.
Yay. All right. Can everybody hear me okay? Can everybody see me okay? All right. I didn't want to use intent-driven network, thanks. It's design-driven network assurance. So real quick about me. I've been doing network automation for over 10 years, first on the vendor side, being an evangelist, a developer, worked at startups, and then I'm now at Major League Baseball, where I started in the network infrastructure team as the sole network automation person, and now I have a very small team, and we focus on not just the network, but other things. And before I jump into this topic of design-driven network assurance, which I really hope blows your mind, I wanted to distill the last 10 years of my experience and journey in network automation in a way that I hope is really helpful, that has made me very successful in what I'm trying to do. I learned two basic reasons why a business leader, will give you money or resources to do network automation or automation in general. And the first one I learned from John Willis from the DevOps days, and it was the expression, aha to cha-ching. So a business leader has an idea, aha, and they want to get it running or implemented or out in the world, and that's the cha-ching effect. That's aha to cha-ching. And it's usually pretty easy to calculate an ROI on aha to cha-ching. And what I discovered about networking, in addition to the aha to cha-ching, how fast can we stand up a data center or something, was the oh crap to all clear, right? Oh crap, something's going wrong. Is it the network? Or all clear, it's not. Or how do we pinpoint accurately figure out, what do we need to do to go from oh crap to all clear? And so once I kind of understood that, I applied it, into what we do at MLB. So for example, everything that we do is about the fan experience, right? We want baseball fans to have a good time. So for example, somebody said, aha, we want to have ticketless entry into our ballpark so that it would, reduce the friction of people getting into the stadium and they'll spend more money, et cetera. So they made this thing that was the aha to cha-ching. And then, when something goes wrong with that user or that fan experience, like maybe that is not processing their facial recognition fast or whatnot, that's the oh crap to all clear, right? So this is a real world kind of way of looking at it. And so then as a network engineer who's like in the bowels of all of that, how do we translate that into a business practice or a business statement, right? We say, okay, well, we believe that we look at the fan experience and we protect and serve the fan experience. And my team builds software to automate infrastructure, so that we reduce risk, we improve operational efficiency and ultimately provide a better service to our business stakeholders, right? Doing this thing that I just said really helped me drive the sale of automation, whether it's when I was at a vendor or I'm trying to, get more money and resources internally. So I hope, if nothing else from this talk, you find that little nugget of insight helpful. So now I'm going to go into the talk here itself. I did a talk back at NANOG 88, which was really heavy on concepts. Like it was like, oh, this is really deep stuff. And they said, can you show us like how you use this in practice? So there's been a lot of concept stuff today. I'm going to show you some demos of how we used this system in anger just recently to roll out, 8 ballparks in Florida, and we went through the operational process. So my hope here is that I'm going to show you something that a lot of us have been talking about now from yesterday and today. This is something that we're doing, and I hope you think about just a different way of doing things by seeing how we're doing it. And of course, our motivation and background here is, we have to do all the things. We have brownfield, we have greenfield, we have 6 different network vendors, 12 different operating systems. We have to do things in, physical places called ballparks that have, data centers on WANs and LANs and wireless, everything. And then when we have people go in to deploy or refresh equipment, it's being done by contractors and smart hands who are on a very tight time frame. So as John talked about, like the aha moment where they did 10 deployments a day, that was the big thing. It's like, how do we, with a very limited staff and a very complicated scenario, do the effect of 10 deployments a day by making sure that that contractor gets in there, does his job, does it, and everything's done, and then he can leave with confidence rather than he has to come back 6 or 7 times to get the job done. So I look at this problem as a network quality assurance problem, much like a software person would look like a software quality assurance problem. And it's not about config management or config generation or config pushing. For us, it's like, how do we know the network is operating as we expect it to? And I'm not using the word intent here, but we want to understand, is it operationally working? And some examples of that are, did they plug in the right transceiver? Did they put in a 10 gig optic that's long range versus a 10 gig optic that's short range, because that will screw up your day? Or is PTP, Precision Time Protocol, as a very complex protocol, did it converge to the grandmaster that you wanted it to? Like, these are really hard operational details that have to work before you can even flow data. So we started with this concept of a design, and I'm going to talk a little bit about what that means a little bit later, but it is not a series of YAML files. It is not an Ansible playbook, right? It's something that we can programmatically reason about so that when we take that design, we can compile it, if you will, to use Creedy's term, and we can produce all the checks that a network we need to know about the network. So imagine if you didn't have something like this and you're a network engineer, you'd be doing tens, hundreds of show commands looking for each little sparkle of data that you're looking for, matching it up to, is this correct? And you're going to mess that up. There's just, the human brain just can't compute all of the things that you want to check. So we automate that process of creating those checks based on the design. And then when we need to change the design, meaning, we're at the Dunedin Blue Jays and we need to add a few new cameras, we have to move cameras around, then the design changed, we recompute the checks, and we can just basically go check the network, and we get 500 checks done in 10 seconds. That's the effect that we're trying to do here. So we kind of broke this up into 2 parts. We have this network computer-aided design idea. Now, I'm going to talk about what we're using at MLB, but it's not a product. It's not an open source project. It's something that we are doing. And what I'm going to show you, and the terms that I'm showing you, are meant to just reinforce the ideas. Just, bear in mind, I don't have a development staff like Chris with 20 people, so, and I'm really bad at naming things. So this is network CAD, or network computer-aided design. And what this allows us to do is ensure that even the design is correct. Meaning, like, if I'm trying to say I have a network topology and I've got a 10 gig optic plugged into, connecting to a 1 gig Cat6, that's a design error. Or if I have 2 links that are in an IP subnet, are they even on the right subnet? So that's what I mean by like a design check. And so we can iterate that before we even try to produce configs and move forward in the next step of the engineering process. I've talked about the checks. We can obviously generate the configs from the design, which makes things really nice. And then the reports that I'm showing here, I'm going to go into a little bit more detail, but this is how we ensure that we're even building the right network based on what our stakeholders, like broadcast engineering and ballpark engineering, what they even really want. So when I talk about NetCAD, it's not touching a device. It's just purely like a CAD system, except without the graphics. NetCam is network computer-aided manufacturing. This is the idea of now that I've got this design, I want to touch the network in some way. I want to push a config, I want to gather data, I want to run these checks. And what you're kind of seeing in this graphic, and I've got 4 or 5 demos that I'm going to go through. They're all about 1.5, 2 minutes long, and I'm going to narrate over them, so those of you in the back who can't see it, I'm sorry, but I'll kind of highlight what's important. But what you're seeing here is we're running a test, gathering all the information of the checks based on that design, and then seeing exactly situational awareness where the failures are so we can kind of start drilling in and fixing problems. Now, over the last, N number of years working on this, I always thought about 4 critical problems, like when we're approaching network automation as a whole. And these 4 very important problems or questions. How do we know we're building the right network? Well, we've had to come up with a process to gather the requirements of all of our business stakeholders. What are all the systems plugging in? What VLANs do they need? What are their subnets, et cetera? You probably do this engineering process. You gather requirements. But now we put that into Netcad, and we generate the report so that we can show the stakeholder, these are the interfaces that I think you said you wanted to use. These are the VLANs. These are the IP addresses. Any element of the design. And we might iterate that, many, many weeks as their requirements might change. Now, once we have that information, we can say, all right, netcad build configs, boop, Jinja templating, we've all talked about that, that's fine. But then we use netcam to push those configs, or even just check to make sure that those configs are okay. So that there's no human copying and pasting things, between systems. It's just an automated process for config deployment, because everybody wants config deployment. Likewise, once things are configured, we want to ensure that the network is operationally running. We would say, netcad, build me my checks. And then we would say, netcam, run my checks, and then we can see our reports. This is the question that we're all trying to answer. The 4th question is how do we transform our culture and processes and automation? And it's taken me almost 5 years at MLB to figure out, all of these things I'm showing you on the screen have to work together. And I could spend 30 minutes talking about just this one slide. But the thing that I'll impress on you all is everybody has to care. Not just you, the network engineer, everybody. Up and down the management stack and across the horizontal to the people that you work with. Everybody needs to have skin in this game. They all have to be in the boat and rowing it. All right, so now I'm going to go into demos. And I think I've got 4 demos. And these are, 1.5, 2 minute demos. So the first one was, we had this thing okay, yeah, we've got Netbox, but how do we get stuff into Netbox so that we can then, set up our monitoring and our network access controller and our, software upgrade process and our config backup? We have all these systems that sit around Netbox. But getting something into Netbox was kind of a pain, because that was kind of a sort of manual process. And they're well, let's build a plugin to Netcad so that it takes the design and puts it into Netbox. So we're going to show you that. All right. So we're gonna build the Dunedin Blue Jays. It's the minor league park for the Blue Jays, and you can see that it's not there. Now here, what I'm gonna do is I'm gonna run Netcad. Did I not bring my glasses up here? Nope, they're in my back pocket. I'm being a grandpa. Why can't I see it? All right. So here we're doing a netcad, show me the devices in my design. So when I use the word design, what I'm kind of saying is, here's a network that we're trying to build. And at a ballpark, we might have 3 or 4 different designs. But in this case, I've got a few designs. We know what their host names are. We know what they're supposed to do in the network. We call this a profile. And based on the profile, we know information about how to programmatically reason about it. The operating system, so we know how to talk to it. The hardware model, the IP address to talk to it. And what are we really doing with the device? How are we managing it with these tools? Now, a lot of the data that you're going to see has been futzed, for the purposes of demo. So don't read too much into it, and don't try to squint. I'll narrate over the important parts. So what's interesting is one of the things that we did was, rather than just doing the networking devices, we said, well, what if we modeled all the connected hosts? And then if we define services around those connected hosts, then anywhere we plug those hosts into the network, the design follows it. Now I'm gonna make my hands do that because it's cool. And what that really means is now if I had to move, say, a camera from one switch to another in the ballpark, I don't have to worry about changing a lot of configure design in the design. I just move its connection in the design, and the design follows that information path and then recomputes what VLANs, IP addresses, whether or not it's using PTP. All of those things just come about because of what is attached to the network. So that was kind of an interesting thing that we kind of did recently. And then we're also able to validate reachability to all of those hosts because we know what all their IP addresses are. Now, here's another example of a report where I'm saying, for this device, these interfaces are in use, and these are the interface profiles. The interface profiles is what defines what the network needs to do. A profile will say, I'm on this VLAN, or I'm using PTP, or I'm a BGP peer. We encode that into profiles that allow us to, programmatically reason about the knowledge graph of our design. We can see that what physical port connection are we using here, because some designs are like, oh, we're using 10 gig, CRs, and some are 10 gig LRs. And since that changes a lot between sites, this information is very critical because the contractor needs to know what parts to take to the ballpark. We might want to know all the interfaces so that if we have to move things around, well, what are the unused interfaces? Or if we just want to know what are the unused interfaces, we can just say, show me just the unused interfaces. So there's many, many reports that go into Netcad. I'm just going to show a couple as they relate to the NetBox integration. So there's cabling, because we need to know how things are cabled. And this gives us our kind of end-to-end connectivity between our devices, not just from the networking devices, but from the connected hosts. And if we tried to do something wrong, like, cat to optics, it would show us a red indication like this is wrong or this data is missing. You need to fix your design before you kind of move on. The other thing that we'll look at is, like, say, link aggregation. How many ports or which ports are in a lag, because we want to understand if a lag is up or what interfaces are missing. So once we have all this data, we just say, all right, push it into NetBox. Make it so, as somebody said. And what's happening here is we're integrating directly with the NetBox interface, and it's programmatically building the device records, the interface records, putting in the IP addresses, creating the lag bundles, and then physically or virtually, making the cabling connections between all the devices. It happened that fast because we're using async I/O, and it's really cool, as somebody said about async. And now we're going into NetBox. We can see we have our new 5 devices. We can see, even how we map the roles and their devices into this. And then if I go into the device I was showing you before, I can look at the interfaces, and then we can see that the interfaces are all here based on the device types, the interface types, the cabling, the IP addresses. And then this data then flows into our network chat ops. So if a ballpark operations engineer wants to say, what's the status of this port in chat ops, NetBox is that data repository that interfaces with those other systems. Wow, how much time do I have? It's like, I'm going to eat up all my time in the demos.
12 minutes on the record.
All right. I've got 3 more demos. I hope you like these. All right, so now we have a contractor out in the field, and we want to know, how's it going, but we can't talk to him. So we can use the NetCam system to see, what's going on and how much work is happening, so that, we're sitting in the back office waiting to see it, so that we can go on to the next device. So here's an example where we're running NetCam, and we're saying, NetCam, check this device, everything about it. Now we can kind of pinpoint what we want to check, but what you're seeing is the actual real time. This is how long it takes to run all the checks on one device. And you can kind of see the aspects of the design that we're checking. There's a lot of them. And in this case, it took 13 seconds to run 214 checks. That'd be a whole bunch of show commands and a whole bunch of pinpointing data. And now we can see the aspects or the situational context of where those errors are. And then if I wanted to see, well, what are those errors, so that I can, see what they're doing, it'll dump out all the errors. And when we talked about what are we expecting versus what are we actually measuring, this is exactly that, what we talked about yesterday. You can see, on this port channel 1, there's something wrong with interfaces. We can see that we expect 2 interfaces, but only 1 interface is up. And this one, we don't have any of the interfaces. Then we look at the cabling. So we scroll up here and we say, yeah, I have cabling. We don't see this cable. We're really using LLDP checking. We don't see these cabling endpoints, which tell us they haven't even physically connected up those devices, so we can't even touch them yet. And here's an example where we're getting data back, but the device and the port information isn't what we expected. Because in this case, we were swapping vendors, vendor A for vendor B, and vendor A gives us these weird MAC addresses in LLDP, and we know what it is, and it's not the device that we want. So this gives us really close situational awareness. When I talk about context-sensitive and situational awareness, it's this level of information so that we can tell the contractor what's going on. Here's an example of, hey, they haven't swapped the optics around or the transceivers. There's a whole bunch of Cat 1 gig SFPs, and we know that they need to plug in some 10 gig LRs, for example. So this isn't like a part of the config. This is part of the design. So you can't reverse engineer a design from configs. You have to have the design as a whole. And here we're looking at interfaces, and we can see like these speeds aren't right, and this one particular interface isn't even up. And so we can sit here and run this command, every 10 minutes just to see how they're doing, and then we know their progress. In this case, here's PTP. We know that PTP isn't working on this device because it's going to come from another device. And so we can't tell the guys who are going to be installing the PTP gear yet to run their test because we know that this device won't be serving PTP yet. Everybody wanted to see an example of config deployment. So that was like, how do we do that? In this case, we made a design change. We had to add some more cameras. So we added some more cameras to the design. I can't make the screen bigger, I'm sorry. So what we're going to do is we're going to do a config check. Now, in this case, we're using some Arista kit that allows us, like Juniper, to push a config in a candidate mode, get a diff back, and then look at it. Now, so we're doing two devices at once, and it's kind of running through that process. We just say, config check, pushes the configs, runs through the algorithmic process to execute the API, gives us back our configs in a diff format, which is what the devices give us. And then we can look at it and we can see, all right, is this change to the design going to reflect what we expect? And it's not just we're turning up new ports, we're adding VLANs, a new VLAN, and we have to put it on the port channel going up to the next device. Last demo. Come on, give me my last demo. Okay, so at this point, the contractor says, I'm done. I think I'm done. I'm ready to leave, go get my beer. And we're like, well, hold on a minute. So we're like, we're going to run a check on this device, because this is the one he says he's done with. Now, we could run all the devices concurrently. I don't show that, but it is fun to watch. And now we know immediately he's not done. Like we already know, like hold on, we're running some checks. We know something's not right, and we can see, like for example, cabling. Something's not right with the cabling, right? In this case, and so once we get the data back, and these check information, we're storing them as little JSON files so that we can explore them. We can navigate the data. The CLI here is just looking at the captured data that we store in JSON. We're going to look at the cabling because if the cabling isn't right, other problems usually aren't really good. So we can kind of pinpoint in and say, I want to look at the cabling errors, and we can see that the management interface wasn't plugged in. And it turned out he just didn't press it in far enough to go click. Right? He thought he plugged it in, and it wasn't. Another case is we look at the interface results, and we can say, I skipped over it. I know you think you plugged all these devices in, but you forgot to power them on. And because he didn't power them on, the interfaces didn't come up. And they're in an environment where they really just can't see all the LEDs. It's not their fault. How much time? 5 minutes? Oh, Jesus. All right. So really quick on theory. What do I mean by design-driven network assurance? The rest of this is slides, no more demo. I think of a design as here's the collection of my devices, and then here's the composition of what I call a design service. Now, every network is going to have a topology, and you can see these are the checks that come with that design service. Same with VLANs, and now with precision time protocol, if you know what precision time protocol is about clocking, there are two types of checks that we do with precision time protocol. The takeaway here is that the design service is the level of abstraction that we think about that gives us the network engineering knowledge about what is good or bad about that design and how to check it. We don't do a level of abstraction like, here's how you do VLANs, here's how you do interfaces, here's how you do routes. Because that's kind of a horizontal abstraction layer. We think in a vertical layer that captures your expertise so that, if we ever want to use PTP in another design, all of that knowledge about validating it and design validation comes with that module. And then we think about, if the network is okay as kind of a quality assurance matrix between devices going one way and the design services going over across the top. So these devices may be different operating systems. It doesn't matter from a design point of view, right? That matters when we actually talk to the device and run checks. But we know, for example, I have this device is good and maybe we can move on. And a lot of vendor products can give you this level of, yeah, it's okay or not. But what's really hard to do is across a network design, is multicast good? Is PTP good across multiple vendors? That's like really, really hard to do, and it's a problem that we have to work with. And I'm probably gonna run out of time, but I'll probably finish with this case study on precision time protocol because it really kind of really hones into this problem. If you're familiar with precision time protocol, there's something that gives you clock, and if you don't got it, your AV systems are not gonna work. And so in our case, we've got two. We've got a primary and a secondary, and that's the grandmasters. And then depending on which one's primary, the interface is either going to be in master or slave mode. That's okay by design, but we know that this port is going to be the master because it's going to provide clock to this slave. And this is what I mean by topology or protocol convergence. Monitoring that operational state of any protocol convergence is really hard to do. So in our design tool, we can say, well, this is what we expect it to be. We know that these two ports, one of them should be the grandmaster. You don't configure that in the box. And we know that these are the expected states. But what are they really? When we run the netcam check and then analyze the data, we can very quickly see that PTP is not okay. But PTP requires that everybody sees the grandmaster. We do. Right? We see some interfaces are down and PTP is saying, I'm in a disabled state. But what this is telling us is that grandmaster isn't on the port that we expect it to be, even though we have a consistent grandmaster seen on all devices. And this is really important. This is like a needle in the haystack type of problem. And we can get that answer in seconds. And if we have a really large network, like say a data center with tens or 20 devices, doing this manually takes a very long time versus this is good. We know it's good. We know what device it's on. We know what interface that it's on, and we can say with confidence to our business stakeholders that the network is operationally correct. How much time? 2 minutes. All right. Everybody wants to know how we built this. This is not really important because it's not a product. I would love to buy a product that does this thing that I'm talking about. So vendors please build products that think this way. But what we did is we treat it like a product, right? We said we're going to build it with Python with a series of modules that we can reuse. Some of that is like our netcad-cam engine. We have kind of this plug-in concept so that we can do that cross-functional network operating system design service module plug-in. We have a repository that's our common widgets, that we use for all ballparks. We might have a design that's all Florida State League ballparks. And then, every ballpark has a little bit of unique tweaking. So maybe this is, the part that's just for the Dunedin Blue Jay. But we build that whole system as an application, basically. We Dockerize it. And then the people who use this, our network engineering and operations team, they'll fire up the Docker container. They'll say, I'm using this site, run checks. We try to make it as consumable as possible. You can see that it's not a pretty GUI. If I had 2 more developers, there'd be a pretty GUI. The benefits that we found using a direct Python approach is all the things that I hated about dealing with YAML and Ansible playbooks, and not to crap on Ansible. It's great, but not for something like this. We have all the ecosystem tools and packages available to Python. If we want to map an OUI to a vendor, there's a library for that. Async is great for doing things fast. Even if you don't have 100 devices, if you have 3 devices and you've got a contractor waiting for you to tell them, is it good or not, they don't want to wait 5 minutes. They want to know right then and there. I always joke about no YAML. Yeah, little YAML is okay, so not only YAML. But anybody who's tried to do anything at scale and complexity by stitching together YAML files knows that it's, eating a bowl of broken glass. It's terrible, right? It is. Okay. What's really important to me, actually, is this 4th bullet. I am training the next generation of network engineers who are learning enough Python so that they can be good at their jobs. I am not trying to turn them into software engineers, right? This gives them a real working environment to play around. I call it cake decorating. I give them a giant cake. It's got all the stuff on it, and they want to write happy birthday and experiment and learn and grow. This is a kind of a safe, sane space for them to do this. So they don't have to write everything from scratch and a CI/CD pipeline. There are challenges, of course. Anything that's worth doing is going to be, hard. There's a lot of time and energy and investment that somebody has to put into doing a product level program or project like this. But it has benefits, right? But some of these are not obvious. Like, expectation setting with stakeholders. If I go to my boss and he's like, why did it take an hour to make a change when I know that they could just jump on the CLI and get it done in 5 seconds? It's like that level of expectation setting about, how quickly can we get something done? You have to manage that, right? And in summary, making time, the design is code. People talk about infrastructure as code. I'm like, this is an application, it is code, and it gives us all the benefit. We version control our design, which means we can go back at any point in time in our version tree and say, rebuild everything, rebuild all the configs, rebuild all the checks. Like, we can roll back because everything is version controlled. And it gives us the quality assurance that we need because we're looking at the operational state. We're validating that before we try to do the next thing with monitoring or performance monitoring. We're not trying to validate config state. This also ensures that our design information is always up to date. Like, who's built a network diagram and then 6 months later it's garbage, right? Or you wrote a bunch of docs and it's garbage. You can't get out of sync. Unless you just don't follow the practice. And most importantly, it's building the skills for the next generation of our network engineers. All right, that's my shtick. This is the link to the nanog. The nanog presentation goes into a lot more concepts, like really digs into like what is a design service, how is it made up, how do checks work, the kind of algorithmic or architecture of the bottom half and the top half of this kind of framework. It's very interesting. A lot of people said too deep, want to see actual, use the thing in anger. So I hope you got a sense of what I'm talking about with situational awareness and design-driven network assurance. Thank you.